Thank you for sticking around for the last presentation of the afternoon. I know you're probably tired and want to go get a drink or something, go to Foothills. So my talk today is on really my lessons learned from building a turn-by-turn navigation app. I used the Esri stack for this, but there were several key components along the way that I had to sort of muddle through to make it all work. And one of them also was building a data set adequate for routing and for these turn-by-turn directions. The impetus for this project was that I had already worked with Meals on Wheels to do a route optimization project. So these are our 29 Meals on Wheels routes in Catawba County, and they update nightly based on cancellations or additions. And our poor route coordinators were prior to this, they were going into Google Maps, and it was just a kind of a nightmare situation that they were dealing with. So this has sort of streamlined their workload from like 5 hours to 5 minutes, something like that. But part of this application is they don't have to write out the directions anymore. It's already taken care of for them. And this is from each in order of client for the entire route. I've also been messing around with, or I've created some web applications that use the JavaScript geolocation API. So I thought, well, hey, I know how to use the geolocation API, and I've got these. I know kind of how to use the routing stuff. So I wonder if I can make a turn-by-turn navigation app. And in my spare time, that's kind of what I did. So this is sort of a lessons learned from that. And I don't know why it's not moving forward. Where's my mouse? This is wonderful. Where is the mouse? Wonderful. Where's the guy? Okay, I'll do it this way. So this is some of the fallbacks with using that I've found a third-party software like Google is that A, addresses might not be up to date, and B, your Centerline stuff might be up to date. So this is actually a new townhome or apartment complex. We didn't originally have Centerline data for it, and Google doesn't have addressing or Centerlines for it either. So I wanted to figure out how we can incorporate that data to create a more robust Centerline data set. So if we actually look at what Google does, they're actually essentially performing a select by attribute query. So they're looking at the address name and they're looking at the street and saying, okay, let me geocode along the street. But it's essentially a select by attribute problem. What they can't do is route directly to that location until they have some interior Centerlines. And those are Centerlines that fall within parcel boundaries. So there's another question of using, is it proper to add Centerlines that are essentially private within a sort of public right-of-way Centerline data set that's going to be used for next-gen 911 or your E911 purposes. So the solution is essentially a select by location method that you have to implement. The other thing I should mention is that whether it's geocoding or whether it's creating a selection set on your Centerlines for that address, it's doing a near analysis. So it's going to try and drop a perpendicular as best it can between the Centerline and your building address. And in this case, it has no idea where it is, and the address is actually farther up north there. So what I ended up doing to be able to solve this select by location problem is, and also create a routing data set that was not going to violate E911 rules or usage. I created another polyline layer I call my Centerline additions. And I essentially had to digitize all these interior polylines within parcels into a separate data set. But for select by location to work, you actually have to have some sort of bounding extent to constrain your Centerlines to create that selection set. So I had to create a second polygon layer to do just that. And it's actually just the parcel boundaries for those center lines. So whenever I digitize center lines for a parcel, I copy out the parcel boundary as well and put that into my boundary data set. And the very basic methodology is when you have your location that you want to route, you intersect it with the polygon layer. You check to see if you do get a hit. If you do, you take that polygon that's returned and you use that to select out your center lines. From there, you can do a near analysis, and it's going to drop you as close as it can right on a perpendicular. Like in this case, it'd be that red triangle along the center line, and so it's dropping you exactly where you need to be. So again, I kind of talked about I went about this. I did it using these two data sets. Because I didn't, especially the Centerline data set, because I didn't want to create a second full Centerline data set just for routing. That was just going to be double the maintenance, and who wants to do that? So if I can just digitize those little additions and append them on to my main data set, that's going to be way better. And it can also be automated. So every night, whatever additions my coworkers add to our main data set, I basically I create a copy of it, tack on my interior parcel center lines, and I've got my routing data set. And so that process is automated. Now there are some drawbacks to this. So like it takes a lot of time to digitize right-of-way center lines. It can take an unlimited amount of time to digitize center lines that are within a parcel. Essentially, you're digitizing driveways. And you have to have some criteria to say, hey, which driveways am I going to digitize? And since I was working with Meals on Wheels, I had them just give me a list of apartments and townhomes in Catawba County. And it didn't take too long to digitize those. But you do have to make sure your topology is correct with your main Centerline data set so that when you do attach it, everything just works. It's all topologically correct. And I had to use ArcObjects to actually build my Centerline data set nightly because there is not an ArcPy script to do that. But once it's created, there hasn't been too much maintenance. And this could actually be a great job for interns. If you guys have interns, you need something for them to do, they could just start digitizing driveways. So one of the aspects of digitizing these interior center lines, as I call them, is you have to provide some sort of road name for it. And in this case, this townhome complex is called Oakwood Apartments. And what I ended up finding is if I just provide a road name for the first segment that enters the parcel, Oakwood Apartments driveway, and then leave the rest of them blank, it's going to provide really good directions. So it'll say turn left or right onto our Oakwood Apartments driveway, but then the rest of your turns inside that parcel, it's just going to say turn left or turn right, and it's not going to, it'll work out really well. So the other major thing that we had to work through was how do we model intersections. So there's multiple ways to model intersections, and especially when you have like a divided highway multi-lane intersection. And it's got to serve the purpose of E911 and your next-gen 911, but it's also got to work for routing. And I found that having an intersection that is defined by a single point where all the lines converge is the best way to solve that. However, you're always going to have one last vertex, which I'm calling like your angle of approach right there, before it actually enters the intersection. And that angle of approach has to be oblique enough that your directions won't think that it's turning. So if you have a sharp angle there, it'll essentially say turn left to stay straight on the road that you're already on, and you really don't want it to say anything. So you have to make sure that angle is pretty oblique. So that's something to keep in mind. And we only had a few of those in Catawba County that I had to deal with. For the most part, we had pretty simple intersections, so I didn't have to worry too much. So now I'm going to talk about actual methodology behind the navigation app itself. And really, the important thing is how you geolocate a user's GPS device, because there's a lot of things that can go wrong with just using the raw point. So the essential methodology is first you need to check, and you can do this, this is for the user and the destination, but not so much the destination because you're typically using an address, and an address, and it's just a little bit simpler to implement. But first you want to determine if you're going to use your selection by attribute or select by location methodology. And so first you'll actually check to see if you fall within one of these polygon boundaries. And if you do, then you can create your selection set with that polygon for your center lines, and then you'd run a near analysis to find that location nearest to your point on that selection set, and you would actually use that point to pass into your solver for routing. There's a second check you can do for your GPS point. You can also check to see if you fall within any parcel. So we want to find the address that you're actually near. So you would first, and I'll have an example of this, but you would first intersect with your entire parcel data set, and if you do hit a parcel, you actually find the associated addresses and use one of those addresses as your point for your solver. Otherwise, your raw location just has to be good enough, and typically with this methodology, like 99.9% of the cases are taken care of. So here's the first example. If you just imagine if you were right up in that upper left-hand corner of the driveway near the house, and you use your raw GPS location, it's going to just try and tack you to the nearest centerline spot it can it doesn't care. It's just looking for the nearest location. So it's actually going to put you on that parallel road, but obviously that's not the right spot you want to be at. So if you intersect the point with the parcel and then grab that address, then you know where you actually need to be when you run that near analysis. The other thing that's important is that you can't just use the XY location from the near analysis on the center line, because you need to still keep the relative side of the road that your user or destination is on. So what I actually do is I calculate the 90% point between your given location, GPS location, and that point on the center line. And what that does is it further guarantees that you're going to be routed in the correct spot. And it keeps the relative location for your left or right turn from the starting location, and for the correct side of the road for your destination on approach. In this second example, this parcel has a couple things going on with it. First, it has two addresses, and they're both different assigned to two different streets. So if you just grab the first address that is returned, you may grab the wrong one. So I always check to see which one I'm actually closest to. And in this case, you're probably going to be up by the driveway, so you'll be attached to the 3760 Cool Branch Drive. And when you select out your Cool Branch Drive center lines and run the near analysis, you'll be put exactly where you need to be. For some reason, if you were back in the back of the property, you would be attached to the Highway 16 one. And obviously, there's no road connecting to Highway 16, so it wouldn't work. But the likelihood of that happening is really, really minimal. So you want to always try and find your nearest address. The last example is this hypothetical GPS location. So if you intersect with your parcels and you find that there are no addresses for that parcel boundary, then you could say, you might think like, hey, why can't I just use my nearest address in general? Well, again, you would be attached to this Highway 16 address, and that's incorrect. So if you don't have an address that you can't intersect with, that's not intersected with your parcel, it's just best to use your raw GPS location. And in a case like that, there's not even a house. So I don't think anybody's going to be driving there anyway. So again, with the methodology of selecting by location first and then using your attributes, if not, to create your selection set on the center lines, it's going to cover almost all your issues. So like I said before, with the address point not having the GPS location has to be good enough. Also, there's one last use case, and that's if you don't intersect a parcel at all. Well, that means you're in a right-of-way. And if you're in a right-of-way, you're probably close enough to a road that you're going to be that the solver is going to attach you to the right spot with your GPS location. Anyway, so you're good to go there. I'm not going to talk too much about I'm probably going to run out of time for the geofencing and some other issues, but I'll just quickly say it took me a few iterations and versions of learning how to create my geofences to have them work like I wanted it to. But each geofence, essentially, you're returned when you ask our server for directions. You're returned a polyline or a series of polylines, and you can use those to create your geofences. And you do that for each segment with a series of buffer intersecting clips to at different spots along your. Essentially, you're buffering at different sizes and clipping and buffering again to create your geofences. And I found that having 3 different types, A, B, and C. So A is sort of getting close to going into a turn, B is coming up on the turn, and C is going out of the turn. Those are going to covered like all 3 types of issues that when I'd want to actually provide directions audibly. So we'd say in 500 feet, as you're coming up, it'd say in 500 feet, turn left on whatever road. And then as you come into it within 150, it's going to say it again. And as you're coming out of it in buffer C, it's going to say in X number of feet, turn left on the next street or right on the next street. Some things I have to do before I actually allow the GPS to sort of take over is once I get my directions back, I have to, as I'm creating my geofence, I have to attach the directions to each fence. But I also have to pre-process them. So phones don't all have the same voice synthesis API, and they'll really botch some abbreviations. So I think I found most of them, and I basically wrote a little function that'll convert them all to the full name or the full word. And then the other thing I can do on the fly as well with my geofences is the geofences based on those A, B, or C types can provide me further information in real time if I want to make any final adjustments for providing actual real-time distance to the next turn or any other things like that. I'm not providing a live demo because I've always been told don't do live demos, and I tested it last night on a random computer and I had issues with connecting my phone to it, so I just didn't decide to do that. But if you contact me, I have my demo behind on a secure server, but I'll put I'll put it on my unsecured server, and I can provide a link if anybody's interested. And I'll be here for a few minutes if anybody wants to actually look at it as well. I've got it here, and I can load it up for you. Are there any questions?
Are you sharing this with anybody else? Like, is anybody else in your county other than Meals on Wheels?
They're the only ones. Well, everybody knows about it, but it's about. I mean, I've showed everybody, but it's a matter of getting traction and seeing the use. And I mean, really, what it comes down to is if you don't want to trust Google for, especially something like building services, where you may have development where no roads have been built yet or addresses have been built yet, but internally you have the data, and you don't want to rely on Google Maps, then this is sort of a perfect application for that.
Have you been able to share any of your data with Google?
I'm not sharing anything with Google. No, I don't know. No, I haven't. They're pretty good about it. Like the first example I thought about showing, they actually have, and it was that Boundary Street one, they actually have the internal roads digitized already. And when I was working through it, I was just typing in 745 Boundary Street without including a unit number. And so what it was doing was placing the point at a perpendicular to the centroid of the parcel. And actually the driveway was like 200 feet to the east. And so it wasn't even getting you in the right spot. But in Google Maps, if you pull that pin inside, it'll reroute you. And then I tried it again and actually put like unit XYZ in, and it routed to it. So I was like, oh, well, this isn't a good example. But in the other one I showed you, they don't have information yet, and if you don't want to rely on their information, then this is a good alternative, I guess. So And it was very exploratory until about 6 months ago, and now it's in production. So.
What are the prerequisite technologies?
Network analysis, I use the Esri stack. So we have our center. Obviously, you have to have a really good Centerline, topologically correct Centerline data set to use, and then a good address data set. But then I just use my Arc server to generate my directions, and then everything else is processed on the fly on the client. So all the fences are built, all the direction, all the words are replaced, all abbreviations are replaced, and yeah. So
that is the JavaScript API.
Esri JavaScript API. That's a native Mozilla. If you look on MDN, Mozilla Developer Network, they've got their API for the voice synthesis, and it's pretty easy to use. It's a JavaScript library, yeah, and it varies from phone to phone. I've found that some of the lower end smartphones don't have all the libraries attached, downloaded, or even the iOS is upgraded. So there's some slower phones where I'm like, the voice synthesis sounds just horrible, and then you'll see, upgrade. You need a system upgrade, and as soon as I do the system upgrade, it's like works really well. So there are some caveats. Obviously it's not perfect, but even on the slower phones. And there's one other thing if you're into JavaScript. So I had a heck of a time getting it to work on iOS. So if this is sort of very technical, but I'm actually having to programmatically emit on-click events, or on an event to trigger the voice to speak automatically versus having a user have to click it. So what I'm actually doing is binding the event. Where is it? So I'm binding the click event to this. There's a div right there, and I'm binding it to that div. And so it's not actually speaking. Well, there's a global variable that it's got the definition, and that's what it's speaking. But I'm binding the on-click event to that div. But with iOS, they have a security thing that says you physically have to have a user click the screen, and then after that you can have your program emit the click events for you. So it sort of unlocks that for the program to use. And for like a year, and there's only 2 threads on Stack Overflow for this, and they didn't really help me out too much, but so it took me like quite a while to figure that out. But once I realized I had to do that, then I actually, on the previous screen where I actually select client, that's where when they click the client, that's where I'm actually having the on-click event handler sort of unlock the programmatic event emitter for me to use. So, yeah. Sure.
Do you have to do anything special around battery management?
So I was looking into a library called No Sleep, which one thing is if your phone turns off, the GPS signal turns off, and that'll kind of screw up your whole thing. So you'll have to hit refresh to get a new set of directions. So I was looking at a couple of libraries that would keep the phone on all the time while the application's running. Didn't seem to work very well, but it's not very. I mean, it's not very battery intensive. I think it's just as battery intensive as using Google Maps, because it's basically you can use a low or high accuracy GPS location that's emitted, and the high accuracy, and you can set it. You can set a return interval as well. So I've got it set pretty high, but it still doesn't eat that much battery power. So, any other questions? Yeah, that's it.